When it comes to mathematical genius, there is one name you need to know, and that is of Srinivasa Ramanujan. He was a remarkable mathematician and could see connections between numbers that nobody else could see. Ramanujan was a self-taught Indian man who, despite having no formal education in mathematics, reached out to a Cambridge professor in the form of this letter and described some of his ideas. That professor, G.H. Hardy, was able to recognize Ramanujan's genius and invited him from India to come over to England and work with him. They had a really productive collaboration that spanned many years, and since this letter is what started such a remarkable story, I thought today I would show you through exactly what Ramanujan said to Hardy that enabled Hardy to recognize his genius and be so excited about it. The letter starts off with a cover page, followed by about 11 pages of mathematics. Now, a couple of these pages have now been lost, along with the original cover letter, but what I have here is a transcription published by Hardy. Let's just have a read of this first paragraph here. It begins, "Dear Sir, I beg to introduce myself to you as a clerk in the accounts department of the Port Trust Office of Madras on a salary of only £20 per annum. I am now about 23 years of age. I have had no university education, but I have undergone the ordinary school course. After leaving school, I have been employing the spare time at my disposal to work at mathematics. I have not trodden through the conventional regular course which is followed in a university course, but I am striking out a new path for myself. I have made a special investigation of divergent series in general, and the results I get are termed by the local mathematicians as startling." Now, G.H. Hardy, whose first initials stand for Godfrey Harold, is one of England's leading pure mathematicians, and Ramanujan is trying to introduce himself to Hardy in such a way that Hardy understands where he's coming from, that he's kind of on the back foot with his situation, and tries to interest Hardy in taking him seriously. Hardy, like many mathematicians back then as well as now, would probably receive many such letters from people claiming to have discovered great things or to be their own kind of genius, and it's probably quite hard to tell who is the real deal. Let's now have a look at the second section of the letter, and it was actually rather unpromising. Ramanujan goes on to describe a result that he must have thought was one of his best, but was actually well known at the time. He is describing something called the gamma function, which is really an extension of the factorial function. For the factorial function, which we would write as n factorial, if n was, say, 5, then this would be equal to 5 times 4 times 3 times 2 times 1. The gamma function could also be written as n minus 1 factorial. So if we were to do the gamma of 5, it would be equal to 4 times 3 times 2 times 1. If this is our complex plane with real numbers and imaginary numbers, the gamma function is well defined on this whole right-hand area for all complex numbers with positive real part. What Ramanujan is describing with this equation here is a way to extend this function to also be defined in this left-hand side area. In this case, that would be for all negative values of z, except for the negative integers. If we draw a plot of z versus the gamma of z, we see it is indeed well defined on all of these positive numbers and for all of the fractional negative numbers, but these dashed lines are the negative integers where the function is not defined. Now, this trick of extending the domain of a function actually is called analytic continuation and was well known as a technique at the time. And doing analytic continuation, you would get exactly what Ramanujan has written here. So although it is not a new result, Ramanujan has independently come up with something that is useful to mathematicians without having access to the papers in which it would have been published. Let's take a look at this final paragraph here, in which Ramanujan says that he's come across an article written by Hardy in which there is a statement that no definite expression has been as yet found for the number of primes less than any given number. I have found an expression which very nearly approximates to the real result, the error being negligible. I would request you to go through the enclosed papers. Being poor, if you are convinced that there is anything of value, I would like to have my theorems published. I have not given the actual investigations, nor the expressions that I get, but I have indicated the lines on which I proceed. Being inexperienced, I would very highly value any advice you give me. Requesting to be excused for the trouble I give you, I remain, dear sir, yours truly, S. Ramanujan. So what he is talking about here in the third paragraph is about the distribution of prime numbers. If we want to find how many prime numbers there are less than or equal to a certain given number x, then we would denote that with the prime counting function denoted pi of x. What we have is a bit of a step function where every time we find or count a new prime number, we add 1 to the tally. And many great mathematicians have tried to come up with a function that would accurately approximate this. Ramanujan goes into a bit more detail about his technique in the first couple of pages of his working. These are copies that I have here, the originals being stored at the Cambridge University Library. Ramanujan claimed that he could easily calculate the number of prime numbers up to 100 millions with generally no error, and in some cases with an error of 1 or 2. Now it turns out that his prime counting technique was not quite as precise as he claimed it to be, but still was some really great mathematics. So perhaps those first 2 results mentioned in the cover letter were not so promising, but Ramanujan then goes on to give over 100 more results that shows just how prolific he is in coming up with ideas and just how much work he's already done. On this third page here, we have the formulas for many sums and integrals that Ramanujan considers to be interesting. On this last page, we have talk of divergent series, and we have written down the now infamous result that 1 plus 2 plus 3 plus 4 and so on is equal to minus 1 over 12. And you might have heard of this seemingly absurd result. I'll link to some videos about it in the description as well. Ramanujan himself acknowledges that to add up all of the positive integers and get a result that isn't positive infinity seems quite absurd. But his confidence in his own methods meant that he didn't shy away from presenting this to Hardy. After receiving the letter from Ramanujan, Hardy consulted with his friend and collaborator Littlewood. A quote from Littlewood was that these results must be true because no one would have the imagination to invent them. It was Littlewood who also went on to later say that every positive integer was one of Ramanujan's personal friends. In Hardy's first response to Ramanujan, he says that he was exceedingly interested by his letter and by the theorems which he stated. However, he says that before he can judge them, he must see proofs of some of the assertions. Hardy then groups the results into 3 categories. These are number 1, results which are already known. Number 2, results which are new but not that important. And number 3, results that are new and potentially important. But Hardy insists that all of this relies on being able to see some proofs of this work. He put quite a few of the results into that first category of things that were already known, and Ramanujan later said that that actually made him really happy because to see that some of his results were indeed already known verified them as being correct and true, because even he himself might have been a bit unsure of a few of them. In category 2, these are the ones that are new but not very important. And the only thing that makes it into category 3, being new and important, is this expression about finding the number of primes less than a given x. He asks Ramanujan to send him some proofs as quickly as possible, and acknowledges that he has done a good deal of work worth publication. He also includes at the end of his reply some notes suggested by Littlewood. After a bit more back and forth, Ramanujan is invited over to England to join Hardy and Littlewood and work on publishing some of these results. Ramanujan unfortunately only lived a short life, and so the things that were able to be published while he was alive were only a small portion of the work that he'd done. But many years on, I believe that mathematicians can still find lots of gems written down in Ramanujan's notebooks. Some of his results might seem at first like random mathematical facts, but many of them indeed give insight into unexpected and surprising relationships between patterns of numbers. I hope you have found it interesting to take a look at this letter which revealed a genius. Thank you for watching, and a special thank you to the viewers who support me on Patreon. It is your support that makes these videos possible to make at all. Also, a special shout out to today's Patreon cat of the day, Stella.